Every single year, entire continents drift several centimeters across our planet's surface. This imperceptible movement sculpts colossal mountains and triggers devastating earthquakes without us even feeling it. Beneath your feet lies a dynamic, ever-changing Earth. Unlike the static world we often imagine, our planet's rigid outer shell, the lithosphere, is not a single unbroken layer. Instead, it comprises a mosaic of colossal, irregularly shaped pieces called tectonic plates. These massive plates fit together like a giant, cracked puzzle, constantly interacting at their boundaries. Understanding these plates is crucial, as their relentless motion shapes every major geological feature we observe. From towering mountain ranges to deep ocean trenches, their influence is undeniable and profound. They dictate where volcanoes erupt, where seismic tremors shake the ground, and even the distribution of continents. Geologists have meticulously mapped these incredible structures, revealing a hidden dance beneath our everyday world. The engine driving this incredible planetary ballet resides deep within Earth's mantle, a semi-fluid layer. Immense heat from the core creates convection currents, much like boiling water in a gigantic pot. Hot, less dense material slowly rises, cools near the crust, and then sinks, pulling the plates along. Imagine a conveyor belt made of rock, slowly dragging the continents and ocean floors across the globe. But this is not a smooth ride. Plates interact in three primary ways, each with dramatic consequences, and the forces involved are almost beyond human comprehension. First, at divergent boundaries, plates pull apart, creating new crustal material from upwelling magma. This process forms mid-ocean ridges, colossal underwater mountain ranges stretching thousands of kilometers. The Mid-Atlantic Ridge, for instance, marks where the North American and Eurasian plates are slowly separating. Molten rock continuously rises, solidifies, and adds fresh basalt to the ocean floor, expanding it steadily. This continuous creation of new crust leads to a profound question: where does the old crust go? The answer lies in a destructive, yet equally vital, geological process. Second, at convergent boundaries, plates collide head-on, producing some of Earth's most spectacular features. When oceanic and continental plates meet, the denser oceanic plate is forced beneath the lighter continental one. This process, called subduction, creates deep ocean trenches and chains of volcanic mountains on land. The Andes Mountains and the Mariana Trench are prime examples of this relentless, grinding collision. But what happens when two continental plates, both relatively light, crash into each other? The result is a geological spectacle of unparalleled scale and power. Neither plate can easily subduct, so instead, the crust buckles, folds, and is pushed skyward. This immense compression forms colossal mountain ranges like the Himalayas, still growing today.
The Indian plate continues to push into the Eurasian plate, lifting Mount Everest higher each year.
Third, at transform boundaries, plates slide horizontally past each other, neither creating nor destroying crust. These boundaries are characterized by immense friction and stress, building up over long periods. When this accumulated stress finally releases, it causes sudden, powerful earthquakes along the fault lines. The San Andreas Fault in California represents a classic example of this sideways grinding motion. Imagine two massive sandpaper blocks scraping against each other, building tension until they suddenly slip. This explains why certain regions experience frequent seismic activity, often without any volcanic eruptions. But the long-term impact of these slow, constant movements reshapes our entire world. Each boundary type represents a fundamental aspect of Earth's dynamic geological system. These forces operate on timescales far beyond human experience, yet their effects are undeniable and pervasive. The relentless dance of tectonic plates has profoundly shaped Earth's climate and the evolution of life. Continental drift has altered ocean currents, influencing global heat distribution and weather patterns over eons. The formation of mountain ranges creates rain shadows, significantly impacting regional climates and biodiversity. Volcanic activity, often linked to plate boundaries, releases gases that can both warm and cool the planet. These geological processes even influence the distribution of valuable mineral resources across the globe. Many ore deposits form where tectonic activity brings deep-seated minerals closer to the surface for extraction. Understanding plate tectonics provides crucial insights into predicting and mitigating natural disasters. Scientists use this knowledge to assess earthquake risks and develop early warning systems for tsunamis. This predictive capability saves countless lives and protects critical infrastructure in vulnerable regions. Moreover, the continuous recycling of Earth's crust helps maintain the planet's long-term habitability. Subduction carries carbon-rich sediments into the mantle, regulating atmospheric carbon dioxide levels over millions of years. Without this geological thermostat, Earth's climate could become drastically unstable, unsuitable for complex life. The forces at play are a testament to the planet's incredible internal energy and dynamic nature. This understanding reveals Earth as a living entity, constantly remaking itself through powerful, unseen forces. The grand narrative of our planet is written in the movement of these colossal, silent giants. From the deepest ocean trenches to the highest mountain peaks, plate tectonics orchestrates Earth's geology. This fundamental concept explains the planet's past, illuminates its present, and hints at its future transformations. The Earth is a constantly shifting canvas, painted by forces far grander than our daily perceptions. Embrace the wonder of our dynamic planet, forever in motion beneath our very feet. If you found this geological journey fascinating, hit subscribe for more incredible explorations of our world and comment below with your thoughts.